Hello and welcome to Dare to Know, interviews with quality and reliability thought leaders. I'm Tim Rogers, and today I'm pleased to welcome Jim McLinn. Jim McLinn is a reliability consultant at Rel-Tech in Phoenix. Jim has a master's in science and solid-state physics from the University of Minnesota and has worked in the semiconductor and biomedical industries. He has broad experience working to help companies become more competitive. During his career, his responsibilities included reliability predictions, leading FMEA teams, running ALT and HALT tests, and working with international subsidiaries. Jim has served on the ASQ Reliability Division Board and the IEEE Reliability Society ADCOM. He's published 3 monographs with ASQ on Weibull analysis, mechanical reliability, and accelerated life testing. Jim has taught a variety of classes and spoken at many reliability conferences around the world. He's also the program chair for ASQ's Reliability, Maintenance, and Managing Risk conference later this year, where he'll be hosting a course on accelerated testing. Jim McLinn, welcome, and thanks for joining us.
Oh, Tim, I'm happy to be here. Really excited to talk about the RMMR conference, which is October 15th and 16th in San Antonio, Texas. We're having that at the Hilton on Westover Hills Boulevard. If anyone's interested in more details, they can go to our website, www.asqrd.org/RMMR, with more details of program and speaker information.
Well, I certainly hope they are interested, Jim. Can you tell us a little bit about the program and some of the featured speakers? Are there any events that you're particularly looking forward to?
Certainly. We have a 2-day conference, October 15th and 16th. It's preceded by a 1-day workshop on accelerated life test, which I am giving on the 14th. And after the conference on the 17th, there's a workshop on decision making by David Otta, also of the ASQ Reliability and Risk Division. That's the sponsor for this conference. Well, let's turn to the conference itself. We start with our keynote speaker, Dr. Ali Mosley, presently a professor at UCLA. He previously was at the University of Maryland in their reliability program, so you should recognize his name.
Sure.
He'll give us the keynote on the first day, which is the 15th.
Jim, have you gotten a lot of submitted talks? What am I trying to say? I have a lot of people asked to speak at this conference.
Yes, we have been publicizing this conference for abstracts through the month of June, and we've got a lot of response. Based on the response, we organized this conference into various groupings of talks. I'll just give you a few examples. Risk-based decision making. We have 6 planned talks on that area, organized into 2 groups, one on the first day for 3, one on the second day for another 3. You'll find, if you're interested in risk-based decision making and what goes on with that's involved with statistics and reliability knowledge, and using that to make the best decisions for the company. That could be anything from we find and fix the problems, or how much financially will this cost us if we don't find the fix and problems, or we choose alternate methods such as replacing in the field, replacing on failure in the field, things like that. Those would be interesting papers on that area, and included will be some on topics we've seen in the headlines in the last month or 2. I can't say more than that yet, but several of the talks will be highly relevant.
Jim, are you seeing a good mix of papers between what you might call academic papers versus more practical papers?
Well, Actually not going to do papers. We're going to do presentations only in PowerPoint this year, no formal paper. But yes, we're getting quite a mix. We have several people from the universities coming, as well as many practitioners. Some consultants will come talk. Additional topics we have are condition-based maintenance, several papers on that, and events interval analysis. That's an interesting thing because it suggests, well, if you know what's happened in the past, you can predict what's going to happen in the future. There are multiple methods for doing that. I'll mention just a few. Weibull analysis is a good one that people have used in the past, usually with hard failures, but they can do it with degradation as well. That's an example of gathering information from a small sample, projecting across a population what will happen in the future. The Weibull tells you about how many will failure per time, but it doesn't talk about when so easily. That's where the event interval analysis is a more statistical method where you can use several different distributions to predict the future and determine about when events will happen. We also have a group of papers on design for maintenance. For those of you who, you can see these are closely related topics because maintenance may be your issue versus planning for maintenance versus planning for failure. That failures may occur in the field or elsewhere. Those have different approaches. The reason is maintenance allows you time to figure out when you're going to come in and do preventative actions to keep the system from going down. That prevents hard failures or loss of time and effort, usually on the part of your customers. In addition, we have accelerated life test, several papers on accelerated life testing. Of course, I will talk about that in general before the conference. You're welcome to take that as a separate workshop. Several authors will talk about that during the conference and all the aspects of accelerated life testing.
Jim, would you say there are some, you touched on a number of things there, but is there kind of an overall theme or focus for the conference?
Focus is probably improvement or prevention of problems is the other way of looking at it. Improving for your customers or preventing problems for your customers. Those are two sides of the coin. One's the negative, one's the positive. That's what we're trying to emphasize here because the world is getting so competitive with regard to certain products. You've seen some, every so often you'll see something in the media, the newspapers, on the internet about products, product recalls. They range from appliances like washing machines and dryers, microwave ovens, to automobiles. They even go much bigger because certain products are maintenance dependent. I'll give you an example, airplanes.
Sure.
Airplanes are terribly maintenance dependent. Two things occur there. You want to keep the planes flying, is what the airlines do, and they want to operate in a safe mode. No incidents, no problems. So these topics address much of these two items, the maintenance side and the safe mode flying. They can be very closely related, though not everybody treats them in the same fashion. Some companies separate quality from reliability from safety topics, as well as from effective design. Think of those as four little silos. One of the things we try and do at this conference is bring the silos together so they're not separate. People are talking to each other, and you have a much more effective product development and product maintenance process once the products go into a field. I've worked with a lot of medical devices, medical instruments over the years. Biggest problem with a medical instrument, keeping it up and running so it can deliver product information. It could be blood chemistry analyzer. It could be monitoring of patients in the field. You want that information flowing in smoothly and accurately, and not be interrupted by machine problems or software problems. This conference really emphasizes the hardware side, though we're planning future conferences we'll talk about the software side. I've already looked towards next year and talked to several people about putting together a track on software issues with regard to maintenance and reliability.
Well, that sounds like a great idea. I was going to ask you, are there people that don't typically attend this kind of conference that you'd like to see more of? Would you say software engineers might be an example of that?
Software engineers would benefit from it. They have a tremendous interaction with hardware, and often it's a software hardware interaction that determines how successful products are. Uh, we encourage more software people to come and learn some of the aspects of hardware. Likewise, we encourage the hardware people to go and learn a little more about software. This year's emphasis is on the hardware side, but as I foreshadowed, next year we hope to work more with the interaction of software and hardware, because that more often than that is the difference between building a successful system and not.
Sure.
It's the old joke when I first came into the market was the hardware is released, the software will be finished 2 years after the hardware is released and the product's in the field.
Right.
We prefer to avoid that. I've worked with companies and products where they spend a lot of time doing that shakeout of hardware and software. And some of it is focused on testing. You mentioned in my bio, I've done accelerated life testing and halt testing. Those are two tools we can use to help shake out hardware and software. I found both. I must have done 40 or 50 halt tests in my life, and I found common problems, manufacturing-related issues, parts falling off that shouldn't.
Sure.
I found circuit board problems. Can you imagine that?
Wow.
In one case, the circuit board wasn't designed properly, or it was designed properly, it wasn't built properly. Give you an idea, circuit board was a mirror image left and right. One side was built properly, the other side was not. So that confused the engineers for a while, because they would get mysterious failures all associated with the left side of the board. We found that in halt, as they eventually found it in testing. We found it very quickly. It only took us a couple days in halt to find that type of problem. We didn't quite know what it was, but we knew there was something there. And once we did the failure analysis, that quickly identified the problem of the circuit board. I've likewise found software-related problems. Sometimes they've had calibrations or setups that weren't correct. I've found temperature compensation in components that wasn't correct. Found that in halt. That strongly affected the board's ability to perform and would have affected the longevity had it not been found early. Things like that, by looking at testing, doing thorough testing, and tracing back, why are we having failures, is asking the questions, is this hardware or software? And if so, what can we do about it?
Yeah, I mean, ultimately, it's a system, right? It's not just hardware and software components, but it's supposed to behave as a single product.
System.
Yeah.
Yes, it's a system, and often because of the silos in corporations, hardware and software are often separated, not intentionally, but they don't get the most effective combination of the two. We'll talk about that to some extent, but many of these papers will point it out from the hardware side.
Jim, do you typically get product designers, either on the hardware or software side, attending this kind of conference?
Sometimes we get product designers. Usually it's one that says, hey, I need to know more about the testing and how I can do better testing during my design development phase.
Great.
And so I can prevent problems or identify. Think of proactive tools. Sometimes we use fault tree analysis or FMEA, other tools like that to try and be proactive. But that's an approach where you create hypothetical problems. Say, how can I prevent it if the seed to this problem were present, or the root cause, if you don't like the word seed. You get a long list. You can't do them all most of the time, so you prioritize the list and do the top ones. In the testing side, you don't have to prioritize. When we do much more thorough testing, be it a multiple stress accelerated life test or a halt test, the failure modes usually prioritize themselves. They start to appear. Then you have to ask yourself, why is this occurring? Is it repeatable? Is it a problem? And how can I fix it?
Yep. Makes sense to me.
So I tell people probably the best thing they can do at the end of the line is do a halt. Even though they're often going outside the described limits of operation, it's a time compression issue. As you move outside the design limits, the proposed design limits, you're compressing time, so in a short period of time, you find future failures. Oftentimes, future failures are dependent upon degradation or creep or some other time-dependent mechanism. Once you realize that and you do some of this overstress testing, as it's sometimes called, you find problems that would take you a year or two in the field to find. You find those in just a couple of days in-house.
Yeah. That's what makes accelerated testing so valuable. I agree.
I've enjoyed doing that in my career. I've had more fun just finding and fixing, helping companies find and fix things and preventing problems. There's a whole, and screening, if you want to go farther, we won't talk about this in this conference, but HASS, H-A-S-S, Highly Accelerated Stress Screening. Once you find the problems, you want some insurance that you won't release questionable products to the field. So oftentimes companies will do HASS in some fashion. Mm-hmm. Sometimes it's a sample, sometimes it's 100%. I've done both. I'll just cite one example.
Sure.
Released a new product, very important because customers used it on their manufacturing line. If their manufacturing line was down, they could be losing $1 million a day. So we instituted HASS, and we did two things with HASS. We set it up, after we did HALT, we set up a HASS test to assure things going out. Secondly, when products were returned, and they were occasionally by customers, no fault founds were always an issue.
Oh, yeah.
If we got a no fault found product, we ran it through a special HASS screen. 90% of the time, we could repeat the customer's failure.
Wow.
Yet the standard testing when product came back would often not find it. Once we did that, we got smarter and adjusted our HASS profile so we caught things before they left instead of finding them after they came back. These are several types of failures. The kind of thing that customers see as intermittent or not reliable, not durable type of products.
Right.
All that one can find by doing the ALT side, if you're very careful.
Wow, I didn't realize that. Jim, coming back to the conference for a minute, you've been involved with this conference for a while. How has this conference changed over the years? Are you seeing any new themes or new topics that are coming up at the conference in the talks, the presentations that are attracting more interest these days?
Tim, I'm glad you asked the question. If you look back, I'm going to just quickly touch on the history of reliability. Reliability in the Western world and in much of the other world came out of the need for having more reliable products, sometimes military, sometimes consumer, appliances and cars. We've gone through phases, as has the quality revolution. At one time we said, well, we'll just build them better. That was an old car theme. We'll just build them better. Well, that's just not quite enough. You have to design them better, you have to build them better, you have to test them better. We've seen, think of those as decades, about 10 years of emphasizing one versus another. We've emphasized software improvements as well after that. That almost describes the last 40 years of reliability thinking. However, we've seen now, as we moved after 2000, we're looking at the combinations. What do we have to do? Not just emphasizing manufacturing better, which is important, not designing better, which is important, not testing better, which is also important. We have to look at the synergy of all those coming together. That's what I've seen in the last 10 years. The predecessor to this conference was called ASTR, Accelerated Stress Testing and Reliability. The ASQ, the American Society for Quality, Reliability and Risk Division, and the IEEE, Reliability Society, used to co-sponsor that conference. And we saw how things evolved over the years. I've been involved with that conference since 2013, both on program, and I was conference chair 1 year. And I've seen these themes evolve, and that's what we ended up with at this conference. While we changed the name, once we're the single sponsor, to RMMR, Reliability Maintenance and Management of Risk. Maintenance is important, but the management of risk is so important in any life support product, in any product where financial. So we've changed the name and we've broadened the topics. You see that reflected in some of the tracks I mentioned to you. It's not just all testing.
Absolutely.
Not just software. It's not just design. It's a synergistic effect.
I think you're right. I think people are becoming a lot more interested in the financial aspects of reliability. That's really getting a lot of the attention of the upper management and other business leaders.
As it should. I did a project 2 years ago with a company, and they had millions of items in the field, and they had been a little quick in releasing some of them, so they had serious risk issues. One of the things I was asked to do was look at the field data, determine the level of risk, and make recommendations for how they should handle it. Recommendations could be wait till failure, go find your worst customers, which we knew who they were, have customers with the worst experience, swap out the systems, those customers before failure. That has two positive aspects. One, the customer knows you're paying attention. Two, you can schedule a time that isn't a big inconvenience for the customer to come swap out the system so that they see continuous good operation in the field. Part of that will be discussed in the management of risk and some of the papers, how best to do that, make those decisions, how to move forward, and look at the financial side as well as the physical hardware side.
Jim, this has been great. I really appreciate you being with us today.
I'm glad you had me. It was wonderful to talk about a little bit about what we're going ahead, and people should go look at the website. I mentioned it before, so I won't repeat it now, but go see, because we're starting to lay the topics and the authors up on the website now. We're right in the middle of the process, finalizing our program, and so you can see some more detailed topics. You might find something of great interest. You might want to come. It's inexpensive to get to San Antonio. We've got a special room rate of $109 a night. It runs from the 13th to the 19th of October. So you can stay if you want to come early, stay late, take your family, whatever you might wish to do. San Antonio is a nice town to be in, and we've got high-tech industry there and not far away.
It's a great time of the year to be in Texas.
October, yes. That's wonderful.
That was Jim McLinn, Reliability Consultant and Program Chair for ASQ's RMMR Conference in San Antonio later this year. For more information about the conference, please go to www.asqrd.org/RMMR. This is Tim Rogers. Thanks again for joining us.